Hi class, let's take a look at example B. And the first part that we can recognize is that your directional vectors are parallel. So directional vectors, and let me just let V1 equal to 2, -1, 3, and V2 equal to 4, -2, and 6. And I'll just say note, vectors are parallel. Since 2 times V1 is equal to V2. So we have vectors that are parallel. Now, the next part of the problem is to check for an intersection. So check for an intersection. Now, for the intersection, you have to check out the x's, the y's, and the z's. And we technically have that for the actual value of the x's. This is going to be 1 plus 2t. So 1 plus 2t. This is equal to 4 plus 4s. So 4 plus 4s. Then 2 minus t. So for the y is 2 minus t. This is equal to negative 2s. And then the last component is going to be 3t. This is equal to 5 plus 6s. And then we have our three equations. So let me just set up equation 1, 2, and 3. Now from this, we can actually solve equation 2. Now, if we look at equation 2, you have 2 minus t is equal to negative 2s. And let me solve for the actual t's to not have any fractions. So subtract the 2's. And then we're left with negative t is equal to negative 2 minus 2s. And then we're going to be dividing by the negative 1. So we end up with the values of the t's. So our values of t, this is equal to 2 plus 2s. Okay, so at this point, we can actually plug it in into any of the previous equations, and then notice that we actually used equation 2, so we want to plug it in into any of the other ones. So let me plug it in into 1. This is 2 plus 2s into 1. And 1 says 1 plus 2t. This is equal to 4 plus 4s, or 1 plus 2 times 2 plus 2s is equal to 4 plus 4s. So we're going to look at 1 plus 4 plus 4s. This is equal to 4 plus 4s. And on the left hand side, we have a 5 plus 4s. This is equal to 4 plus 4s. Let me fix this s. Okay, and then after the subtraction of the s's, we're gonna end up with the following statement. In this case, we end up with the values of 5 is equal to the values of 4, which happens to be false. Now, since we technically have parallel vectors, in this case, parallel vectors in this case, no intersection, we can conclude that these lines are in fact parallel. You can see from this angle, you can barely tell, but here you can tell that the lines are not intersecting. So let me just write it up. There's no intersection. The lines are distinct. And I'll just say hence, we have parallel lines. And then let me just add in here, no intersection. Oh, I actually had it already there. Okay, so when you end up with a false statement, that's the indication that there's no intersection. And then you also have to check that you have parallel vectors. Let me just add to my last sentence. Hence, we have parallel lines. Since we have parallel vectors, and no intersection. Okay, since we have parallel vectors and no intersection, we must have parallel lines. That's actually it for this one. And like I said earlier, it's a little bit hard to visualize it. We can kind of zoom in here and you can see that, yes, your lines are not actually intersecting. And then here, I'm not extending the domain for the lines everywhere, just the line segment for the purpose of the exercise.